I have to start recording and then do that or else it echoes. Okay, so in 9.3 we're going a little more in depth with things. Okay, 9.2 we only had x's on the bottom of our equations. Now we're going to have them on the bottom and the top. Okay, we'll refer to the numerator just for this beginning part as p of x and the denominator as q of x. All right, so, but remember how like we said that the domain was everything except where x equaled h, and we said it couldn't be h because that would make it equal 0?
Yes.
Yes, okay, so the denominator can equal 0. We're dealing with the same thing. So the domain of f of x, so of the whole thing, is all real numbers except for those which q of x equals 0. Okay, so the denominator equaling 0, that is the problem area. All right, so that's what we're focusing on today, is that the denominator cannot equal 0. This first part, we're just kind of talking and looking at things. Talking about things. So we have 3 different graphs here. These are all rational functions. That's the name of this, rational functions. The first one is negative 2x over x squared plus 1. And it makes this cool graph thing right here. It goes whoop. All right? Just kind of, thank you. See if I can come up with another one for this one. The next one is 1 over x squared minus 4. And that one's whoop, whoop, whoop. All right, and the last one we have x plus 2 times x minus 1 over x plus 1, and it's got this funky little graph thing here. All right. Oh. I don't know. All right, that went too far. All right. So we're just going to talk about these things. In the first rational function, there's not a value of x that makes the denominator 0. Okay, so let's look at that graph thing, or the equation. I know, it's super big. So is there anything we can plug in for x that makes this whole thing equal 0? No, because we would need this to equal negative 1, right? Negative 1 plus 1 is 0. But nothing squared will equal negative. So we don't have an issue here. The denominator can never equal 0 on its own, so we don't have any problems. All right, so that makes it to where it's continuous. All right, continuous is that word because it has no jumps, breaks, or holes in it. In other words, you can draw that whole thing or trace the whole thing and never have to pick your pencil up. Okay, so pencil that doesn't leave the paper. If you can draw the entire graph without ever picking your pencil up, then it's continuous. Continuous. Remember that word. Continuous. A parabola is continuous. Yes. All right. A line, straight line is continuous. Absolute value is continuous. All right. Now, in the second function, all right, x cannot be 2 or negative 2. So let's look at that equation. Make it giant. All right, so x can't be 2 or negative 2 because either way, if we plug those in, square them, they equal 4. 4 minus 4 is 0. So x can't be 2 or negative 2. Let me zoom back out. All right. And the last one, this one, x can't be negative 1. Because if you plug negative 1 in, plus 1 is 0. So those are the numbers. If you see what happens at negative 2 and 2 and negative 1. There's a space. It's like an asymptote. Like it gets really, really close but never touches on both sides. Okay, so there are asymptotes there. And there's a space. We had to pick up our pencil there. So those are called discontinuous. Discontinuous.
The first 8 are just going to be telling whether they're continuous or discontinuous, right?
Kind of. All right, so there we go. We okay with that? That this one, it's continuous, you can draw the whole thing. This one had to pick it up, so it's discontinuous. Same thing over here, discontinuous. All right, just talking in general now, not about these specific graphs, but just in general. If a is a real number for which the denominator of a rational function f is 0, okay, so let's think about what that's saying. The denominator of a rational function, so we're talking about the bottom of the fraction, and a is some number that makes that denominator 0. So a is our problem. Then a is not in the domain of f. So the domain is going to be all real numbers except x can't equal whatever that a number is. So it's everything but a. Okay, so the graph of f, if there's some a that exists, the graph of s is not continuous or is discontinuous. At that point, at x equals a, whatever that a is. And what we're focusing on today is finding that point, and that is called a point of discontinuity.
Spell that.
D-I-S-C-O-N T-I-N-U discontinu I-T-Y. Okay, D-I-S-C-O-N-T-I-N-U-I-T-Y. Discontinuity. Yeah. Now I'm really self-conscious about that. And I'm recording. Yay! And first, second, and third period get to listen to this tomorrow. All right.
Were you not here?
Huh? No, they're doing it tomorrow. I won't be here in the morning. All right. So those are points of discontinuity where the denominator, whatever makes the denominator equal 0. So that's what we're going to find. All right. So to find points of discontinuity, we're going to practice spelling again. I'm not going to spell it out loud because that didn't turn out very well. So to find those points, we need to find the values of x that make the denominator equal 0. Very good. You can say it out loud. You don't have to whisper it. So let's do that. For a, we're going to set the denominator equal to 0. So x squared plus 2x plus 1 equals 0. And we're going to find what values of x we can plug in there to make it true. So we're solving a quadratic.
No.
Told you we'd come back to this. So our methods of doing this, graphing, so you find the zeros. So you can graph it, you can factor it. You can use the quadratic formula. And the other one is complete the square, but I think everybody blocked that out of their heads. Okay, so which way y'all want to do this one? Let's factor it. Okay, so what factors can we plug in here?
I'm gonna go with 1 and 1.
1 and 1, because if we do plus 1, so when we multiply 1 times 1, it gets 1. When we add them, it gets 2. So that worked. Now what do we do? Set each equal to 0, each factor, which they are the same thing. So I'm just going to write it once. And then we subtract 1 to the other side. So what does x equal? -1. So that is our answer. And remember, we're looking for points of discontinuity. This point will not be on the graph. And I like to abbreviate like that. Okay? You don't have to write that on your homework. I just want to remind you that we're finding where the graph doesn't exist, where there's a problem, where you have to pick your pencil up. Any questions?
Can we graph our homework?
Can you?
Like, can we just
Mm-hmm, yeah. Okay, let's do the next one then. So what do I set equal to 0?
X squared plus one.
The denominator, very good. And how should we solve this? We could graph it.
You subtract, just, no, factor.
Yeah,
Subtract one and then square it.
yeah, okay.
Square it, I mean, not square
Since we don't have that middle term, the b term, we can just subtract 1 to the other side.
Oh, wait, but you can't.
Oh, what happens when we take a square
it.
root?
Imaginary number.
Plus, minus, and what's the square root of negative 1? I is the square root of negative 1. Now, if you remember, it said real
So is this?
numbers A.
So there's no point.
So there's no point of discontinuity, so it's continuous. I'm gonna write not real number. So it's continuous. All right, on the last one, of course, I made a typo. I'm going to change the denominator. I'm sorry. To be x squared minus 3, just so we have another type of example, because that one would have ended up being imaginary and would have been the same. So we want a different type. So I set my denominator to equal 0. I can add 3 to the other side. How do I get rid of that squared? Square root it. What happens when I square root both sides? Plus or minus. And can we simplify square root of 3? No, I mean you could get a decimal, but that's about as far as you have to go. So, how many points of discontinuity does this one have? 2. It has a point of discontinuity at x equals square root of 3 and at x equals negative square root of 3. So those are your answers. Yes. Let me, just so everybody can have it, I'm going to write out the quadratic formula for you.
Yeah, I'm gonna go.
You may want it on, because there's ones that factoring would be kind of hard. But you can always graph it too. So it's big fraction negative b plus or minus square root b squared minus 4ac 2a.
I was surprised when I was confused.
Quadratic formula, in case you need it. Any questions? I think there are 2 on your homework that are continuous. Just so you can kind of check yourself.
Oh, okay.